Hi, in this video we're going to find an unknown side length when we've got one triangle inside another. Let's look at these two triangles here. We've got two right angle triangles like this and like this. And remember, we can use trigonometry to relate two of the side lengths of a right angle triangle and an angle of interest in the right angle triangle other than the right angle. So let's see what we know the most about in one of these triangles. We can see with this bigger triangle, we've got this side length of 8.2 centimeters and we've got this angle 31. Whereas in this other triangle, we only know this angle and we don't know that side length, and that's all we've got. So we're going to use the bigger triangle first. So let's use this bigger triangle. But notice that this top length on the triangle, this one here, is shared between the two triangles. It's on this triangle, but it's also on this triangle as well, isn't it? So that's probably a good side length to work out, because then once we know this top side length, we can use it in the smaller triangle, right? So I'm going to give it some variable name. Let's call it y, because we've already used x down here, so we can't reuse it. And let's just draw out the triangle separately to help out. So we've got this triangle here, this right angle. The angle of interest, other than the right angle, is this 31 degrees down here. And we've got the y at the top, and we've got the 8.2 centimeters here. Now remember how trigonometry works. We label the sides of the right angle triangle first, based on the sides that we've got. So this side length is one we've got, and this side length is one we've got. We're not involving this side length because the side is not labeled with a length. Now remember, the side opposite the angle of interest, this is the angle of interest here, and the side opposite it is this. We call that the opposite. So I'm going to put an O in a circle, O for opposite. And this side length here of the 8.2, that is the longest length of the right angle triangle. It's opposite the right angle. And we call that the hypotenuse. I'm going to use H for short. And then remember that we then select the right trigonometric ratio. So the mnemonic we can use is SO, CA, TOA. And that allows us to choose which trigonometric ratio is the correct one to use. Now, we're involving, in this problem, O and H. So we're going to use this one here, the O and the H is here. And what that's actually short for, the SOH, is sine of the angle. So we use theta generally to mean the angle of interest in the right angle triangle is equal to, and then over here you got opposite divided by hypotenuse, like that. So that's what it's short for. We explored that in a previous video. So now let's just substitute in our side lengths and angles. The angle of interest, the theta, is 31 degrees. And then we've got opposite, which is the y, over the hypotenuse, h, which is 8.2. Now we want to get y on its own. We want to get rid of this over 8.2 under the y. So we just multiply both sides by 8.2. And we get 8.2 sine 31 degrees is equal to y. Let's do that on my calculator. 8.2 sine 31. Don't worry about how your calculator works out the sine of 31. And then y is 4. I'm going to put lots of decimal places because we're going to use this value in a subsequent calculation. So 2, 2, 3, 3, 1. That's good. Trigonometry is quite sensitive to rounding errors, so be really careful about not rounding your values too much. So, okay, we've got this y at the top is 4.22331. So this is 4.22331. Right, cool. Now we can concentrate on the smaller triangle up here. So this smaller triangle here. And we can see that we've got that side length of x that we're trying to work out. So let's draw this triangle now. So we've got the 47, this is the angle of interest at the bottom. And then we've got the 4.22331 at the top. And then we've got the hypotenuse as the x here. So again, let's label the sides. Well, the x is the hypotenuse of this triangle, the longest side. And again, that 4.22331, it's opposite the angle of interest, the 47. So that is the opposite, O. And so we're going to use sine again. So remember, sine of theta is the opposite over the hypotenuse. So we substitute in sine of theta, which is sine of 47 degrees, equals the opposite, which is 4.22331. over the hypotenuse, which is x. Now, this time it's a bit harder because the variable's in the denominator. But remember, we had a nice little trick to sort of deal with this. Let's suppose that I had 8 divided by 2 is equal to 4. How could you rearrange those numbers while still making it true? Well, you can swap the 2 and the 4 to get 8 divided by 4 equals 2. That's still true, right? So in general, with a division like that, you can swap the thing you're dividing by and the result of the calculation. So I can do the same here. I can swap this thing I'm dividing by, the x, and the result of the calculation, which is sine of 47. And that allows the x to escape the denominator. So if we do that, we end up with x is equal to 4.22331 divided by sine of 47. And if we do that, so let's get rid of this, on our calculator, we get 4.22331 over sine of 47. You might be able to use the answer key on your calculator to reuse your previous result. We get 5 point, and what is it to one decimal place? So it's 5.8. So the answer is 5.8 centimeters. Let's just do a quick check. That seems sensible. Well, it does seem sensible because the hypotenuse here is going to be slightly longer than the 4.2 here, and this is 5.77. So that makes sense.